Have you ever asked an AI a question and got an answer that felt like pure genius, only to ask it something else and get something completely, totally wrong? Yeah, you are not alone. Today, we're going to pull back the curtain and see how these incredibly powerful language models actually get tested and how we can turn them into tools we can genuinely trust. Let's dive in.
All right, so first things first, we have to talk about the core problem that everyone in this space is trying to solve. It's a phenomenon called an AI hallucination. And honestly, it's one of the biggest hurdles in artificial intelligence right now.
And this isn't some made-up example for a presentation. This actually happened. A real lawyer based an entire legal argument on court cases that just, well, they didn't exist. The AI literally invented them out of thin air. It's a perfect high-stakes example of an AI confidently presenting pure fiction as cold, hard fact.
Which, of course, leads to the big question, right? How is that even possible? How can a tool that can write poetry and explain quantum physics also just make stuff up? It's a puzzle we really have to unpack if we're ever going to be able to build trust in these systems.
Well, the answer really gets to the heart of how these models are designed. See, we tend to think of them like a super encyclopedia, like a database of all human knowledge. But that's not what they are at all. So let's look at the why behind these crazy mistakes.
Okay, this is the most important thing to understand right here. A large language model isn't a fact checker. Its one and only job is to predict the next most likely word in a sentence, based on the insane amount of text it's been trained on. It is a master of language patterns, not a guardian of the truth.
And that's exactly why these hallucinations happen. If the AI doesn't have a solid fact to pull from, or if your question is a little vague, it just falls back on what sounds right. It fills in the gaps with the most probable sounding words, creating an answer that is confident, articulate, and completely fabricated. This analogy just nails it. You know, think of that kid in class who always has their hand up. When they know the answer, they're brilliant. But when they don't, they still give a super confident, well-structured response, just hoping they're close. That, in a nutshell, is an LLM.
So if these models are basically expert guessers, how in the world do we build tools we can actually rely on? Well, it all comes down to a really rigorous system of testing and evaluation, and that's what we're going to get into next. When you're grading an AI, it really boils down to two main approaches. On one hand, you have intrinsic evaluation. This is basically asking, is the language itself any good? Is it grammatically correct? Does it make sense? Then you have extrinsic evaluation, which is much more practical. Did the AI actually do the job you ask it to? Did it summarize that article correctly? You absolutely need both to get the full picture.
To really find a model's weak spots, you can't just wait for it to fail. You have to actively try and break it. That starts with adversarial testing, feeding it tricky prompts specifically designed to trip it up. Then there's red teaming, which is all about stress testing for safety, for bias, for any harmful stuff. But at the end of the day, the gold standard is still human evaluation. Sometimes you just need a person to look at an answer and say, yeah, that's good, or nope, that's nonsense.
Now, human judgment is fantastic, but it's slow and expensive. So we also need objective, automatic ways to measure performance at scale. This is where automated metrics come in. These are specific mathematical tools designed to score an AI's work.
Let's start with the classic called Rouge. Yeah, it stands for Recall-Oriented Understudy for Gisting Evaluation. It's a mouthful, I know. But its job is actually pretty simple and super important. It figures out how well an AI can summarize something.
Rouge is the go-to metric for summarization. The way it works is it compares the AI summary to a perfect human-written one, and it just measures the overlap of words and phrases. It's basically asking, did the AI pick out the same key points that a human did?
This is the perfect way to think about it. Imagine you and your friend both read a news story and then list the three most important points. Rouge is just a way of automatically comparing your lists. The big weakness, of course, is that it's only matching words. It doesn't really understand if you captured the same meaning using different language. And that's where a more modern, much smarter metric comes in. While Rouge is busy matching specific words, BERT's score goes a whole level deeper. It's designed to understand and compare meaning.
And this is a huge, huge step up. Think about it. An AI could rephrase an answer perfectly using totally different synonyms. A metric like Rouge would look at the word overlap and fail it. But BERT's score is smart enough to see that the semantic meaning is identical and give it a high score. It's a game changer.
So this is the crucial difference, right? The focus is on meaning, not just vocabulary. If the correct answer is, the sky is blue, and the AI writes, the color of the sky is azure, BERT's score gets that they mean the exact same thing. It's evaluating comprehension, not just memorization.
Okay, so we've got all these different tests and fancy metrics. How does this all come together in the real world? How do organizations take these powerful but flawed prediction engines and turn them into reliable tools that a doctor or a lawyer could actually use?
It's really like a recipe for building trust. First, you test your model against massive, standardized benchmarks to see how it stacks up on general knowledge and truthfulness. Next, you combine the speed of those automated metrics we talked about with the nuance and wisdom of human reviewers. And finally, and this might be the most critical step, you run specialized, custom tests for the specific job the AI is going to do.
And that right there is the bottom line. A language model fresh out of training is just raw, chaotic potential. It's this continuous, rigorous process of testing, measuring, and refining that builds the bridge from a powerful guessing machine to a tool that we can genuinely, truly trust to help us work and learn.
So the next time you use an AI tool, maybe don't just ask what can it do. A much more important question to ask is, how do you know it's right? Because that's the question that is going to shape the entire future of this technology.